Hi everyone. We're going to do the 3 commonly missed problems from homework assignment number 2 for anyone who wasn't sure how to solve it based on the feedback that I gave you. The first one that was often missed is question number 13, where you had to find the area of the shaded region. Many of you solved this partially correctly, where you found the area of the orange square in this case, but you forgot to subtract the area of the white square. So when they ask us for the area of the shaded region, they only want the part that is orange, which is right here, and not the part that's white. And so this is the part that you have to subtract out. So to do that, many of you knew area is length times width. And so I'm going to do my area of the big one, which is x plus 3. And then I'm going to do that subtracted by the area of the small one, which is 2. So to start with the first area, let's make sure you can see that. Okay, so to start with the first area, I'm going to do x plus 3 multiplied by x plus 3. And you can use the FOIL method here because it's a binomial multiplied by a binomial, or you could use the box method. And so when you do that, x plus 3, x plus 3, you're going to end up with x squared plus 3x plus 3x plus 9. And so the area of the large orange square, when I simplify it, ends up being x squared plus 6x, because I combine these like terms, plus 9. But I still have to subtract out this part right here, the area that is a 2 by 2 square. And so if I do that here, subtracted by 2, oops, that's a squared, or 2 times 2, then what I get in here is a 4. And because the length and the width don't have any variables, it's just a constant, which is 4. And so I'm going to add that here, subtracted by 4, which is the white area. And then now I'm going to combine like terms. Pretty much everything stays the same. X squared plus 6x, they don't have anything to combine with, but this part, plus 9 minus 4, ends up being plus 5. And this right here is my answer. You might have had a problem that was similar, but not the same numbers. And so if that's the case, I think all of them had a 2 by 2 square in the middle, but the length for the different problems might have been a little different. So you might have had x plus 7 instead of x plus 3, but you solve it pretty much the same way. Okay, on this problem, when you say that the answer is x squared plus 6x plus 5, the second part of this question asked you what the units were. And because it's area is always units squared. And so in this situation, they don't tell us what the units are. And so we just say units squared, or another way to say that, would be to say square units, which I think is how they wrote it in the problem. But the next problem that was commonly missed was dividing a polynomial by a monomial, which was question 18. And many people knew to divide the first problem, the first part, but weren't entirely sure how to solve past the first term. And because this is a monomial on the bottom, we don't need to do long division. What I think helps make more sense is I rewrite this as negative 16 to the x to the 8th. Hang on, let me try to rewrite that and make this maybe a little smaller. Okay, so negative 16 x to the 8th, and then I'm going to divide this 4x cubed. I'm going to put it to each term. So 4x cubed plus, because my next term is positive, 4x to the 7th over 4x cubed. And then you can either do plus and then put the negative at the numerator, but I'm going to do it here, minus 8 over 4x cubed. Okay, and so basically what I've done is I've taken this one term and I've divided it by each of these. That one and that one and that one, which is what I have to do if there's addition or subtraction, especially in the numerator in this situation. If it was in the denominator, we would have to do long division. Okay. So now I'm just going to divide each section. So I have this part first, which would be negative 16 divided by 4 is negative 4. And then I still have my x, and then I'm going to use my quotient rule for powers, where because these both have the same base of x, I can just do 8 minus 3, or I could expand it and cancel it out, and you would get x to the 5th. In the next problem, it's going to be plus, because I have a positive divided by a positive. I'm going to do the same thing. I'm going to look at the numbers first here. 4 divided by 4 is 1, and so that's just going to be x, or 1x. And then I'm going to use the quotient rule again, where I have both x's as my base, and so I'm just going to do x to the 7th subtracted by x to the 3rd, and so I'm going to get x to the 4th. And then this last one is where a lot of people kind of got stuck, and so it's subtracted, first of all, and then second of all, we can still do this part here with the numbers. So in this situation, 8 divided by 4 is 2, but it's going to be 2 in the numerator. And because I don't have an x, I have to keep that x cubed at the denominator. And so the first two terms for this answer look normal, but the last term is a fraction, and that last part is my answer. It's back. Perimeter. The last question that a couple people weren't sure how to start, and I thought would be worth going over because there is a question similar to this on your test, is finding the perimeter. And one thing I wanted to note, actually, because we're adding and not multiplying, perimeter is always just units, not units squared. So our answer is going to be feet, not feet squared. So when you're adding up perimeter, you add all of the sides. And in this situation, we don't have any that are distributing. So like if there was a 2 there, I would have to distribute that 2 to the 4x and the 2 to the negative 3. But none of my sides have that. They're all just straight parentheses on their own. So that means I don't have any distributing. And so I can just sort of write it out like normal. And so I'm going to write negative x squared plus 5x plus 2x squared plus 5. Oh, I'm going to run out of room. Hang on. I'll make that smaller. Ah, way too small. Okay. And then there should be a plus here. Plus 4x minus 3. So again, because I don't have a number on the outside of any of these parentheses right here, there's no distributing. Or you could say that I'm distributing a 1 and that keeps everything the same. And so I'm just going to drop my parentheses. So I'm just going to have negative x squared plus 5x plus 2x squared plus 5 plus 4x minus 3. That's a minus. And then I'm going to use the commutative property to combine my like terms. So I have squareds, and remember to take the sign in front of it. And so I'm going to write negative x squared plus 2x squared. Those terms can be combined. And then I have a 5x and a 4x. So I'm going to write those next to each other. Plus 5x plus 4x. And then I have, in this situation, some constants. And so I have plus 5 minus 3. And again, make sure that I'm putting that negative with the 3 because that'll kind of change your answer if you forget it. So plus 5 minus 3. And now I'm just going to combine the ones that are alike. So I'm going to combine these ones together, my squareds together, my x's together, and then my constants together. And again, this is a subtraction sign. So negative x squared, which is the same thing as negative 1x squared, plus 2x is going to just be x squared, because that's the same thing as 2 minus 1, plus 9x, because I'm adding 5x plus 4x, and then plus 2, because I have 5 minus 3, and then it's that as feet, which they may or may not have asked you in the question, and that's your answer. Again, you might have had a similar problem, a triangle, but the side lengths might have been different, but the approach would still be the same. So if you have any other questions about homework 2 or about any of these problems specifically, make sure you email me and let me know. And I wish you all the best of luck for your tests and your upcoming assignments, as well as a good weekend.